Guys, what's up? Mr. Miller here. A little bit of music intro for you there. Maybe you've heard that song before, Bruce Springsteen, Hungry Heart, one of the songs I grew up with back in the day. What I want to do is walk you guys through some problems in Math Excel on solving logarithmic equations. And to begin, the first problem that they throw at us, at least what they're giving me, is solve this logarithmic equation. Now, what's the base in this logarithmic equation? The base is 10, right? Because if we don't see the base shown on the word log, it's automatically base 10. And what we're trying to do is figure out what the solution is to this equation. We're trying to figure out what x is. So let's write this down. Maybe you can do it with me. We'll work it out together. And let's solve this thing. We need to figure out what x is. Okay, so I'm going to switch screens now, and this can get a little unnerving because I have to go back and forth, but right now I have no choice. If I can figure out a better way to do it, I'll start doing it that way, but for now this is the best I can do. Okay, so we're asked to solve log base 10 of 124 minus 6x equals 2. The first thing we need to do is get rid of the log, right? We want to flush that down the toilet. We want to get rid of that log, and the way we're going to do... Okay, that was terrible. I'm sorry. I shouldn't talk like that. Anyway, we need to get rid of the logarithm, and what we do is we use the base, because if we use the base, what's going to happen is the base and the log, they're going to undo each other. So since the base is 10, what we want to do is raise this side using a base of 10, and same thing with this side, use base 10. So when we do that, we're going to get 10 log of 124 minus 6x equals 10 to the second. Right? And again, I'm not just pulling 10 out of thin air. I'm choosing 10 because that's what the base of this logarithm is. Remember, if we see the word log and there's no base shown, that means but it's the common logarithm. And since it's so common, we don't feel like wasting time to write the 10. Any other logarithm for right now, if it's not base 10, the base has to be shown. Okay, so what's happening here? The 10 and the log go bye-bye, and the 124 minus 6x is now going to drop down. 10 squared is 100. And what we want to do now is solve this for x. We're going to subtract 124 from both sides. Those go bye-bye, negative 6 down, right? 100 minus 124 is negative 24. We're going to divide both sides by negative 6. And this tells us that x appears to be 4. All right, let's check just to make sure that that is in fact a solution. So I'm going to plug 4 in for x in my original equation, this guy right here. And I want to see if it's going to equal... Shoulder shrug, question mark. I don't know if these two things are equal yet. 6 times 4, that's 24. 24 minus 24 is 100. And log base 10 of 100, I have to ask myself, we'll do this on the side, 10 to what power would give me 100? Well, that's 2, right? That would be 2. All right, I'll use a different color. That might be better. Right. Okay, 2. 10 squared is 100. So this side all becomes 2. And lo and behold, it matches the right side. I'm now confident that 4 is my solution. Let's go to Math Excel, punch it in, and see if Math Excel likes it. It better, because I know it's right. Okay, where are we? Where are we? Here we are. All right. X equals 4. All right, good deal. Okay, how am I doing on time? All right, try to keep this under 10 minutes. All right, let's do slightly harder one. Okay, really quick. To solve this one, you would raise both sides using 27 base 27 and then simplify. But let me do one of these where there's a little bit more involved to solve it. Okay, so it says round to the nearest whole number as needed. That's a sign that we might be getting decimals in this answer. So they say solve it. Really, that's going to be more of an approximation than actually solving it. So we have log 3x plus log x, and in both of those logarithms, it's base 10 equals 11, and we're trying to figure out what is x. All right, so here, let me switch screens, Alt-Enter to get a full screen, and let's go back to the whiteboard, get it from the computer. Okay, so we had log base 10. Again, we're not going to write the 10 because it's a common logarithm. If the base isn't shown, it's always base 10 of log x equals 11. And what we want to do now is try to solve this for x, but the problem is we have an x in this first term and an x in the second term, and we can't just smush these two things together and say, oh, that's log 4x. No, 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 no. That's not going to work. Don't you dare do that. What we need to do is use our property of logarithms. So if you remember, log base b of x times y, in other words, we can take the product of something and then take its logarithm if we want, or we could take the logarithm of each thing individually, okay, b, and then add those two results together. So here I would take the log of x, get something, take the log of y, get something, smush those two things together, and I would have the answer just as I would if I multiply first and then take the logarithm. So let's apply this property, this property, in reverse. Because we have a sum, we're going to write it as a single logarithm. So remember, plus product. Product means I'm going to be multiplying stuff together. I'm going to have 3x times x. It's still going to equal 11. And now 3x times x, that's 3x squared, equals 11. And now I need to solve this for x. I need to solve this for x. And to do that, I'm going to have to get rid of this log part. So to get rid of this log, we're going to use base 10 because that's what the base of this logarithm is. So I'm kind of running out of space. So I really don't want to write a second line over again. I'm just going to squeeze the 10s underneath. We know that these go bye-bye because they're inverse of each other. My 3x squared is going to drop down. And now I have to figure out what 10 to the 11th is. And that number is going to be very, very, very large. As a matter of fact, I think I have a graphing calculator on my desktop. Maybe. Let's see. Oh, you know what? No, when they did software updates last year, they cleared that off. Okay, well, I have a graphing calculator here. I can just do it and then tell you what it says. 10 raised to the 11th is a really, 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 really big number. And in fact, it's so big, the graphing calculator spits out for me one. I'll write it on here so you can see what I'm saying. So you can see what I'm saying. Yeah, and you can also see what I'm seeing. The calculator spit out this. That's scientific notation. I have 1 times 10 to the 11th. So the number is so large that even the calculator can't show me all the digits, so it's putting it in kind of a shorthand. We're going to divide both sides by 3 because we want to get x squared by itself in order to get x by itself. Now I have x squared equals, let's figure out what this is. I got to divide this 10 to the 11th by 3. And what I'm going to do now at the same time is take the square root. Okay, so let me clarify. So basically what I'm doing is this. I'm taking 10 to the 11th. I'm going to leave the 1 off because it's not serving any purpose other than taking up space. On the calculator, I'm going to do this side in one swoop. I'm going to take 10 to the 11th, divide by 3, and then I'm going to take the square root of it. So this way I save myself some writing. So when I take the square root of that thing inside the square root, I get x is roughly 182,574. It said round to the nearest whole number. And so that should be our answer. 182,000, excuse me, 574. So let's go to the thing. Let's see if it likes it. 18, I keep saying 18. 182,574. Okay, all right. Hey, I got it right. Good deal. All right, guys, I hope you found this video somewhat helpful. Please, please, please make sure that you get that quiz completed by tonight. Well, tonight. I'm assuming you're watching this on Monday, the due date. But anyway, if you're watching it before Monday, March 12th, the quiz is due by 11:59 p.m. Monday, March 12th. Keep up the great work, guys. I really do appreciate it. Talk to you later. Bye-bye.